Hey, welcome back. So far in our program we have used the match case statement. However, in this video you'll see that the match case statement fails at one point. And you will understand where that exactly fails and what is the alternative to fix that issue. So let's go back to our program and we will improve something now. And you'll see how match case will not serve the purpose this time, as I just mentioned. So let's run the program and I'll explain you what I want to improve. So currently, if we want to add a to-do item, we first press add, press enter, and then enter the to-do item. Play soccer, for example. You press enter, then add again, press enter, and so on. But I want to change this. I want to make this program more user-friendly by allowing the user to enter the to-do just after the add command. So in one line they can enter add followed by the to-do item, and then they can press enter, and that will add play chess to the to-dos.txt file. So let me close the program. I hope you understand what we aim to do, and let me explain you how we can do that. So, if we let the user enter add followed by the to-do item, that means in user action we're going to expect that entire string. So user action will look like this. For example, add play chess. It will contain this string. So if we execute that, user action now contains that string. And then in the match case block, can we check if that string contains the add command? So in other words, here we want to try to understand if the user meant to add something. We try to understand the user intent. Currently, we only check if the string matches this 100%. Yes, we do strip it out of the white space, but that's all. So we want this now to be more intelligent. So what I'm thinking of is to use the in operator. Let me explain what in is. This is in. If you have a string, for example add, you can check if that string is contained inside another string, such as add play chess. If you press enter, you're going to get true. And if you change the expression to something else, such as is show in that string, in that case you're going to get false. So using the in operator, we can find out if the user intends to add or do something else. This, of course, can also be done like this: add in user action, and you get false because user action is actually at play chess. We defined it somewhere in here. User action is this string. So we can make use of this expression now and add it in here. Add in user action. So if the case is add in user action, and we see already that we do have a red underline here, which means PyCharm already found an error. But we can try to execute it if we are not convinced that this doesn't make any sense from a syntax point of view. So if I run the script, we will get a syntax error. So case add in user action doesn't work because you cannot enter expressions after case. Case only expects a pattern, such as a string. And the solution here is to use the if-else conditional block. So we want to delete match and we want to replace case with if add in user action. We want to replace case show with if show in user action. So that string in that variable. We want to replace case edit with if edit in user action. And we also want to replace case complete with if complete in user action. And also, finally, if exit in user action. Now, we do see an underline here, which indicates that something is not correct with this code. And the problem is that we have too many levels of indentation. So notice that while true is the first level, and then it contains the code under it, so we have one indentation here, and then if should be here, but it is currently here. So we want to unindent the entire if block. To do this, you can, if you are on PyCharm, you can select the entire block by putting your cursor here, press and hold, and then drag down until you go to the end of your if-else block. So that's the end of the block up to the break statement, and then so you can now press Shift Tab, and that will unindent the entire block. So if I press Tab again, it goes where it was. If I press Shift Tab, it goes back. And that's it. That's the code. We can try to see if it works. So add new to do, for example. And yeah, it seems to be working, but we still get asked to enter a to-do. So we still have to fix some things here. So this is the logic now. If add is in user action, this block will be executed. So in that case, we don't want to ask the user for a to-do because we expect that the user will enter the to-do inside that variable. So therefore, we want to remove that, and we want to extract that to-do from user action. We can extract the to-do using this syntax for colon inside square brackets. That will give us the part after add. So let me show you that in the Python console. Let's suppose that user action is equal to add clean the bag. Right, now user action for colon will give us clean the bag only, without the add part and without this white space. And this is called list slicing. It's a list slicing operation. So basically what we're doing here is we are extracting all the characters of the string starting from the character with index 4. So A has an index of 0, D has an index of 1, the other D has an index of 2, space has an index of 3, and C has an index of 4. So we get from C and everything that comes after C. So we get the entire string. and we put it there. If you change this 4 colon to something else, for example 8, you're going to get that. If you change that to 9, you're going to get clean. If you change it to 11, you're going to get more and more and more. So the idea is that when I entered 8 here, what we get is the character with index 4, which is C, the character with index 5, 6, 7, and that's all. So every character that comes before 8 but after 4 is included in the slice. So 8 is not included, 9 is not included again, 11 is not included. So only 4, 5, 6, 7, 8, 9, 10, these characters are included in this slice. So that's about slicing. Slicing is helping us to extract only part of the string, only that part of the user input that we are interested in. So we store that to do in the to do variable, and that's about it. So if I run the code now, I say add fix the computer, press enter, and I say exit. The program will exit, and in todos.txt we have fixed the computer as the last to-do item. So it's working well. Let's check the show case now. So if show in user action, then we want to print out everything. So let's run this, try show. Yeah, it's working well. So show in show, it's true. So what's happening here is that the user entered simply show, and what you do is you say basically show in user action, and you get true. So that's a condition, but the entire if block is like this: if show in user action, do something. In this case, let's print hello and press enter. Oh, I've got a typo, user action, sorry. Here, user action, press enter, hello, yeah. So this is being executed whenever this is true. If it is false, such as if show in user action, in this case we will not get print hello executed. So that's how if works. Now we have multiple if conditionals here. So what's gonna happen actually here is this. The interpreter will start to execute these lines, so it asks the user for an input, and then it executes this line. It checks if add is in user action. If it is, it executes this and that and that and that. Once it finishes executing these lines, then it goes and executes this other line. It checks if show is in user action, and then it executes this if that's the case. But if you entered add as a user, then actually this will not be executed. Still though, the interpreter will check this. So it checks every other block, this one and this one as well. So I think we have some unnecessary code here, because if the user entered add, then why does the interpreter have to check the other ones? Because logically, if the user entered add, they didn't mean show, right? So there should be a better way to do this, and I'll show you that in the next video. So see you there.